All right, so let's have a look at 1 and 2 here. So for number 1, okay, how many moles? What am I looking for? Number of moles, which is N. Okay. And it tells me it's calcium carbonate, which will help me to get the molar mass. Okay, so that'll be 40.08. Okay, plus 12.01 plus 16 times 3. All right. So that was perfect timing. 40.08 plus 12.01 plus 48 is 100.09 grams per mole. And the last thing they tell me is 125 grams, which is little m, or mass. Okay, so 125 grams. Perfect. Okay, so now N equals little m over big M. This one I don't have to do anything except plug in my numbers. 125 divided by 100.09, okay? And that's going to give me about 1.25, I would think. Exactly what it comes out to. And then you have to punch that into the calculator. 1.25 moles. All right, that's the 3-mark mole equation question because it's the simplest. Okay. Questions on that one? Okay. All right, in number 2, they're asking us what is the mass. So we're looking for little m. They tell us N, number of moles, 2.7, and they tell me that it's lithium phosphide. So that'll be 6.94 times 3, because there's 3 lithiums, plus 1 phosphorus, which is 30.97. And 51.79 grams per mole. Okay, so I have N, I have big M, I'm looking for little m. So N equals little m over big M. I need to get little m by itself. So I need to move big M. To move something, I perform the opposite operation. Multiplying will make it cancel. What I do to one side, I do to the other side. And now I have my formula.
Will we lose marks if we don't show that?
No.
Will we just put m times?
If you just show me the manipulated formula, that's what I'm looking for. Yeah. Okay, so now that I have that, m equals 51.79 times 2.7. $139.83. What are my units?
Grams.
Grams. How important is it to have that on there?
Very important.
Well, if you want that mark, it's pretty important. Okay. All right. I'm going to push those questions back up here so you can work on 3 and 4, and we'll go over those in a couple minutes. So looking at number 3, okay, we're looking for how many molecules. So we are being asked to calculate the number of molecules, which means this number is now going to be involved. Avogadro's number, which tells us how many molecules are in a mole, okay, for any substance. Okay, they tell us that this is iron 3 oxide. Okay, so I can calculate the molar mass, 55.85 times 2 plus 16 times 3. Okay, so 159.7 is our molar mass, and that's grams per mole. All right, and they also tell me 230 grams, which is mass, little m. All right, so even if I've got no idea what I have to do with Avogadro's number, even if I'm completely lost at this point, what can I calculate right now with what I have? I can calculate the number of moles. So even if you're totally lost, do that, okay? That's, at least you're going to get half the marks for the question because that is what you can do right now. And if you don't remember what to do after that, at least you have half of it now. Okay? Now, I know that's you guys because you all remember exactly what to do after. But sometimes getting at least that far helps to like trigger your memory and go, oh, right, now I do this. Okay? So next step then is to calculate what I can. Little m over big M will get me number of moles. Okay. So we've got 230 grams divided by 159.7 grams per mole. So we're looking at 1.44 moles. Okay. So now, I have the number of moles, and I have Avogadro's number, which tells me how many molecules per mole. So what do I do with those two numbers? Multiply them together. Okay, this is how many are in 1 mole. I have this many moles. Multiplying them together will give me the total number of molecules that I have in 1.44 moles. So, number of molecules, okay, equals n times Av's number. Okay, and so that's going to be 1.44 times 6.02 times 10 to the 23. So taking that number there with all the decimals and multiplying it by Avogadro's number, which is in brackets. 8.67 times 10 to the 23. Molecules. Questions on that one?
I just have a question. So if it turned out to be like 1 mole for the answer, would you have to show this calculation, or could you just like, because it would just be equal to 6.02 times?
You would not need to show any other work.
Okay.
Since that situation will never happen, you won't ever have to worry about it. Okay. All right. Any other questions on that one? Okay. How many people have the calculator with them today that they are going to use next week? Okay. If you don't have your hand up right now, you need to get the calculator you're going to use next week on your unit exam really soon. Okay? I had people yesterday, they're like, well, I'll just use my phone. I'm like, facepalm. No, you won't. You can't have your phone during an exam. Okay? Kind of a security issue there. Okay? No, you can't use your phone during an exam. Please make sure you go out and at least get it cheap, you know, Walmart special or dollar store even I think has some. Okay, you don't have to spend a lot of money on it, but you do need a separate calculator. I only have a couple of loaners, and they're on a first come, first served basis. You don't want to be the one without a chair when the music stops, okay, on exam day, and you're doing this by long division on paper. Okay, I would not want that for you. All right, so make sure that you have a calculator before exam day so that you become familiar with its operation. Which button do you need to use in order to get the exponent on your calculator, stuff like that, right? Because I spent, I think it was in period 4, I probably spent 15 minutes figuring out somebody's calculator and how to get it to show the stuff properly. If that had been exam day, you'd have just been cooked, okay? There'd have been nothing I could do for them, all right? So, but that's, we want to avoid that, you know, understandably stressful situation and not have to do that. So make sure you get your calculator before that, okay? All right. Still need some time on number 4 then.
No.
Some people do. Okay. Be nice. Okay, so let's have a look at number 4. So in number 4, they give me the number of molecules. And they're wanting me to calculate the mass. Okay, so the number of molecules here is 5.42 times 10 to the 21. Avogadro's number is this, 6.02 times 10 to the 23. Do I have more or less than a mole? Less. A lot less. Okay? No, it's on the periodic table. And it's on the front page of the exam. All right, so I've got that. I know I'm looking for little m. If I'm going to get little m, I have to have n and big M. Big M's not a problem because they told me the stuff I'm dealing with is nickel 2 nitrate. Okay, so nickel is 58.69.
Yep.
All right, and then how many nitrogen do I have?
2.
2. plus 14.01 times 2. And how many oxygen? 6. All right. Whoop, 69, not 68, 69 plus 28.02. That's my 2 nitrogens plus 16 times 6. All right, 182.71 grams per mole. All right. So I know the number of molecules, and I know the number of molecules in 1 mole. I need the number of moles. How can I get it with those 2 numbers? Divide them. Yeah, the opposite of what I did in the last question. Okay, I have the number of molecules, 5.42 times 10 to the 21, and if I divide that by the number of molecules in 1 mole, I will be left with number of moles, and it'll be a decimal. So in brackets, 5.42 21 divided by 6.02, 23. All right, so I have that number of moles. It's a very small number of moles. That's what we said, okay? 0.009 moles. All right, now that I have N and big M, I can now calculate my mass. Okay, so I'm going to take my formula here and I'm going to manipulate it by multiplying both sides by M, which will leave me with that. Okay, so I will have then 182, sorry, mass will equal 182.71 times 0.009. So I have 1.64 grams. Okay, pretty small amount. Then you definitely did something wrong. Okay, I would imagine it had something to do with your brackets if you got an exponent as big as what you got.
Didn't you see multiply? No, I thought.
Okay? You got to make sure that each number is enclosed in brackets. If you don't enclose them in brackets, everything I write after the 21 is included in the exponent, which will give you crazy numbers. Okay, so each number needs to be enclosed in brackets. Okay? All right, questions on how that one worked? All right, so now, as a man of my word, I have done 4 more examples, okay, today. Now tomorrow, I may not get to 4 examples because it's a short class and I'm doing your unit exam review tomorrow, okay? But what I will do is I will post on Google Classroom a video of me doing 4 more, okay? Because that's the next best thing that I can do in case I don't get to them tomorrow. All right, questions on this stuff? Okay, are we starting to feel okay about how we do it? Because, I mean, really, there's only 4 ways, right? You basically just have to memorize the 4 ways and you're set. I really want you to memorize. I want you to understand what you're doing, but, okay, worst case scenario, there's only 4 ways, okay? All right, what I want you to do is continue working from the digital workbook, okay? Just practicing these because that's what gets you good at them. So, I'll call that up here. Actually, I had it here. It was a bottom of, actually, we'd be on page 12 by now. Okay, so I've got from 8 kind of on here, so you can kind of work on those and pick up where you left off if you have the file open on your computer, okay, or on your computer, on your phone. Okay. So for number 8, we're looking for how many moles. So you're looking for N. In number 9, you're looking for the mass. Okay, so little m. Okay, just kind of keep going with those. We'll be working on some tougher ones that have like word problems associated with them, where you have to kind of read the story and figure out what it's looking for. We'll work on those next week. But I do want to look at number 7 right now. Okay, for number 7, which contains more atoms? A mole of iron or a mole of oxygen gas?
Iron. No way. It's gotta be iron.
Okay. Which is more, a dozen donuts or a dozen eggs?
Donuts.
Okay, that's usually where people go with this question. A mole is a mole, Coder. A mole is always 6.02 times 10 to the 23. And if I was talking about anything other than oxygen, nitrogen, chlorine, fluorine, or any of those special elements, that would be true. Okay, if I have 1 mole of sodium atoms, I have 6.02 times 10 to the 23 atoms. If I have 1 mole of iron, I have 6.02 times 10 to the 23 atoms of iron. But oxygen is O2. So when I have a mole of oxygen gas, I have 6.02 times 10 to the 23 molecules of oxygen gas, which is twice that number of atoms, because there are 2 atoms in each molecule. Okay? So all that question is asking is, do you understand the difference between atoms and molecules? Okay? If I asked you that same question for how many atoms are there in 1 mole of water, it would be 3 times 6.02 times 10 to the 23, because every water molecule has 2 hydrogens and 1 oxygen. Okay? So it's just asking you, make sure you understand that a molecule is made of more than 1 atom. Okay? That's really all that's asking. Okay, so let's get to work on 8 and 9, and if you finish 8 and 9, you can keep going on to 10.